Hello friends, we are bigdatahandson.com. Today is day 20. We are going to see decision tree algorithms like decision tree classifier and decision tree regressor. So previously we have seen the k nearest neighbor, logistic regression and other algorithms we have seen. So this is our website bigdatahandson.com. So you can visit our website. If you have any doubts, you can message us in this number 9789844, or you can send email through support@bigdatahandson.com. And previously taken videos will be uploaded in here our YouTube channel bigdatahandson.com. If you subscribe to our channel, you will get all the updates. So you can see here till part 19 we have uploaded. So today is part 20. So let's see today's algorithm. So today, as I said, we see decision tree. So decision tree is a CART algorithm, CART. That means classification and regression trees. So that means it is capable of classification and regression algorithms, both classification and regression capabilities. Decision trees are compatible with both types of task, regression as well as classification. And computational efficiency, since decision trees have in-memory classification models, they do not bring in high computation costs as they do not need frequent database lookups and arbitrary complicated decision tree boundaries. So actually we use this decision trees when you have a rule based decision making, then we use decision tree. Okay, so as human things like for example, if you want to make a decision, uh, for example, if you want to go to home, there will be two ways or three ways maybe. So you make a decision. For example, if this way I go, then I will face maybe uh, so you will have two ways. So you can go this way or this way. You will choose which way is more comfortable, or you can go faster than that way. So you will choose this way, right? So that's a decision you are making. So in that way, decision trees also will work. And comprehensible and transparent. They are extensively used by banks. As I said, when you have a rule based decision making, we use decision trees. So we use banks for role approvals just because of their extreme transparency of rule based decision making, right? And another thing is, in decision tree you don't have to uh, give a pre-processed data, because a decision tree can work with uh, data for example, if the data has missing values, or it has categorical type of data, not not a problem, because decision trees bring in the capability to handle a data set with a high degree of errors and missing values. So usually for decision tree we don't pre-process the data. As the data is, we give as it is, and then it will give a good accuracy on the data as well. And when to use decision tree, so when you have error rates in your data, when you have highly error rates in your data, for example, they have relatively higher error rates but not as bad as linear regression. And data compatibilities, decision tree can handle numerical and nominal data, so you don't have to convert the categorical data into nominal data. And impact of number of attributes, so this is a problem actually in decision tree we have. So not only in decision tree, so all other algorithms also face this problem. So what's the problem is, see, these algorithms often tend to produce wrong results if complex. That means when you have more number of attributes, that affects the that impacts the performance of the algorithm. So uh, when you have highly complex data, don't use dictionary. So alternatively, we have another algorithm, that is random forest, that works even you have a complex data also. So humanly intelligible factors are present. For example, in case like customer segmentation, it would be very hard to imagine a decision tree returning accurate segments. Okay, so let's take this example data. We have like temperature outlook, humidity, windy, played. This is what we are going to predict. For example, there may be a match happens. So the match played or not, we are going to predict based on the temperature outlook and humidity, windy, these features. Okay, so in temperature we have mild, hot, cool. Outlook we have sunny, overcast, rain. So three categories we have. And humidity we have a numerical one, and windy we have yes or not. Okay, so as you can see, we are not we have some categories type of data, so we are not going to uh, convert the categories into numerical one. So keep as it is, and then now we are going to create a dictionary for that. For example, the dictionary will look like this. So you can see we have outlook. So on outlook we have three categories, right? So it's split it into three nodes. So the nodes are nothing but split for the value of a certain attribute. For example, the attribute is outlook. So the nodes are split into three parts. One is sunny, overcast, and rain. And edges is nothing but the outcome of a split to next node. Okay. So these are the edges, like you can see. This one is edges actually. For outlook, it's an edge humidity, and for edge, here that is yes, and this edges as well, no and yes. So this thing you can call leaves as well. Leaves you can call. And for the node which is starting here, right, outlook, is called a root node. From root node only it is just splitting out. And then okay, so for example, if we have a sunny node, and then it is splitting based on the humidity. We have less than or equal to 75 or greater than 75. Then it is splitting the values yes or no. Okay, so yes and no, these are the values, played or not. The attribute is played or not, our outcome. Here is our outcome. Okay, and we have entropy. So what is entropy? Actually, let's say you have a bowl. In the bowl you have a fruits, right? So you have only apples. So what is the probability of uh, choose a fruit that is apple? So of course, in the bowl we don't have any other fruits, only we have apple, right? So the probability is 1. So what about two fruits? You have apple and orange, so probability will be decreased. So now the probability will become 0.5. So if you have a three fruits, then again the probability will decrease, right? So that's the measure of impurity. That means in a bowl, if you have uh, different types of fruits, then that is a impurity, right? That's what the entropy measures. Actually, let's say here in the example, so entropy decides which node to split or not. For example, here in the leaf node you can see this is an impured leaf, right? So it decides to split the uh, nodes based on some conditions. Here you can say humidity greater than 75 or less than 75, or windy you can have yes or no. It's placed based on the conditions. So entropy decides whether I want to split or not. Okay, okay. So to measure the entropy, we have summation of minus pi log to pi. Okay, log base to pi. uh, to find the entropy of play golf, for example, yes we have, no we have, there is some impurity you can see. So to measure the impurity, we can calculate the entropy value of play golf. Okay, so for s we have 9, for no we have 5. So that's what here given, 5 comma 9. Okay, and here we'll give the 5 and 9 value, and we'll calculate the probabilities, that is 0.36 and 0.64 is the probability. For example, totally we have 14 fruits, so the probability will be 5 by 14 and 9 by 14. That value is here 0.36 and 0.64. This probability value will give to this equation, so minus pi log base 2 pi. So the result will be like this, minus 0.36 log base to 0.36, and for 64 also minus 0.64 log base to 0.64, and then the result is 0.94. It's the impurity measure of this play golf attribute. Okay, so now if you have more impurity, then you need to split, that means you have to split the node. Okay, if you have impurity, that means you have to split the node. It will split the node until you have a zero entropy. Okay, so to measure the impurity, we have another method also, that is Gini index. So Gini index or Gini impurity measures the degree of probability of a particular variable being wrongly classified when it's randomly chosen. So the same concept here, what entropy does, the same thing Gini index also does. But when compared to Gini index and entropy, Gini index is best. Why? Is because, so in entropy we are every time we are just taking log, so that will be slow. But here we don't have any log taken, or exponentials we don't have. Simply 1 minus summation of probability square, that's it. So what the Gini index is. Okay, and then we have information gain. So we'll see information gain. The information gain is based on the degrees in entropy after data set is split on an attribute. Constructing a decision tree is all about finding attribute that returns the highest information gain. So here if you see in the decision tree, how the decision tree knows I want to start from outlook. Why? Is because the outlook attribute, it has more information gain. If it has more information gain, it starts from the attribute, and then after splitting this attribute, how he decides, I need to use humidity attribute, because after the outlook we have the large information gain is humidity, then comes windy. Okay, so this selection of attributes decided by the information gain. Okay, so in information gain you can find like gain of t comma x, t is the attribute, x sorry, t is the outcome we are going to predict the play golf. Outlook is then x attribute. Okay, equal to entropy of t minus entropy of t comma x. Okay, so entropy of play golf we already found here, it is 0.94, right? And then we are going to uh, calculate the entropy of t comma x, that is play golf, that is outlook. Play golf and outlook, that is 0.69. Subtracting these two values will be 0.247. This is the information gain of outlook column, outlook attribute. Okay, so like the same way we calculate the information gain for all other attributes like humidity, windy, and then yeah, these columns will find, and temperature also. So as you can see, this is the table where we found the information gain. So the gain for outlook is 0.27, the gain for humidity is 0.152, the gain for temperature is 0.029, the gain for windy is 0.048. As you sort it out, then you will find the first column, the root node is used outlook, then humidity, then windy, then only the temperature will come. Okay, based on these attributes we constructed the decision tree, right? Okay, this what all about the decision trees. So now we'll implement it. I will open spider. Okay, now let's create a new file. Save this file. Okay, now first let me import the pandas numpy libraries. Import numpy snp and matplotlib. Okay, now let's run this. So to demonstrate the decision tree, I'm going to use the same data which we used for k-neighbors, that is uh, iris data. So I'm going to use, in my system I have the iris data with the labeled data. That means uh, if you load from the scalar, it comes actually categorical data, it will convert into numerical, but here we don't convert. So you can see we have categories here: iris, etosa, vesicular, vaginica. So the same data is. So I'm going to read from the file pd.read.csv to read the csv file. So here we'll give the path, that is data sets slash iris data. Okay, now let's run this line. So as we know, we got the data frame, so which has 5 columns. First of all are independent features, and the last one class is our dependent feature. Now let's split the data x and y. Data dot ilog. The first 4 column is the starting to 4, that is for independent features, and then for y the last column, or you can simply say data of class dot values to convert the data frame into numpy arrays. Okay, so now we can see we have x and y. So and then what we need to do is we don't have to categorize the y variable, keep as it is. Now we are going to split the dataset into training and testing. So let's import the function sklearn dot model selection. In the model selection module we have the function train test split, and it will return 4 values, of course: x train, x test, y train, y test. And let's call the function train test split and give the data x and y, and we need to give the test size 0.1 randomness using the random state parameter. I will set to 0. Okay, so now we got 4 more variables, that is x train, x test, y train, y test. So now we got the training and testing data. It's time to build the model. So we know that for every algorithms we have a class in the sklearn module. So now the class is decision tree classifier, and the class is inside a different module. The module is tree. So the decision tree is inside the tree module. So if you press control space, it will show you the drop down. So now you can see we have a decision tree classifier and decision tree regressor, because decision tree is a cart algorithm. Okay, now let's create an object for that. Name it as classifier, called decision tree classifier. Okay, and here in the decision tree classifier we have some parameters to give. So we have to specify the criteria. So the criteria is nothing but which function to use, whether entropy or Gini index. So the default is Gini index, you can see here in the criterion, or you can say entropy also. Okay, and we have some other variables also here. This max feature random state you can select to fit the randomness, and because this entry always will give a different uh, results, so you can set the random state also. And what other We have max leaf nodes to specify the maximum uh, leaves, and that's it. We have some other features also. I think you can specify the depth of decision tree. Yeah, max depth is here. So you can specify the depth of decision tree actually. Okay, let's keep as it is the default one. So we are going to use the criterion default, that is Guinea index, and now we are going to fit the classifier to our data, fit into training and testing data. Sorry, training data, extreme, white train. Select these three lines and run these three lines. Okay, so now we have fitted the data into our data set, X train and Y train. Now we are going to predict the test results. So classifier dot predict, predict of the X test. So the prediction also, you can see it will give you the same the categories also. Actually it will not give some numbers, it will give the categories. You can see iris virginica, iris vesicolor, iris setosa. uh, so you can see the whitest also of the same one actually. So you can see iris virginica, iris virginica, iris vesicolor, iris vesicolor, setosa, setosa, virginica, virginica. Okay, so let's check the accuracy of this decision tree using the confusion matrix. Scale dot matrix, import confusion matrix. Let's call the function confusion matrix, and you need to give test and prediction result, widespread. So you can see the same yesterday we saw, right? The same result we have, only one is wrong prediction, because the data is like that. So for every algorithm, the data, using the data, if you create the model, it will give the same accuracy actually. For k neighbors, for confusion, sorry, for decision tree, if you use the same accuracy is giving, only one prediction is wrong, you can see. Okay, so now okay, I will show one thing here, that is I'm going to import from sklearn dot tree import export graphics. So this is a function which will be very useful to visualize the decision tree. So how the decision tree is making the decisions and making the trees, the flow we can see using the export graphics function. So this export graphics function, what it will do, it will give you a dot type of file. Using the dot type of file, you can convert it to png and you can visualize the decision tree. Okay, so to do that, you need to call the function export graphics. Here you need to give some parameters. We see that pressing the control I, so you can see decision tree. First parameter is the tree, the object you want to give, the object is classifier, right? So this is our tree, and then the parameter is out file. Out file is out underscore file is the path uh, where the file is going to store. So this I will just give the name of dot file. It will give you a dot formatted file actually. So and then what we have, max depth we don't want, feature names we want. The feature name is nothing but the column names, feature underscore names. So you want to give the feature names here, that is sepal length, sepal width, petal length, petal width, this one. Okay, so and then the next parameter is, let's put comma here. Okay, now the next parameter is class names. Class names is the output column. So what are the output we can get? We can get iris etosa, this is classes. Okay, we can simply say setosa. And the basic color and Vejnika is the class names. Okay, and then the next parameter is, we need to give proportion. Okay, default as false. Okay, rounded, so rounded will give true. So to round the boxes, rounded equal to true will give. Okay, nothing. Okay, we'll run this. After running this in your files, you can see a dot data. See here, you can see this is the dot data which our export graphics function gives. Actually, this is the uh, tree, actually decision tree of our classifier. So to visualize this, what we can do is simply we need to convert this dot to png actually. Okay, so simply dot to png. So now you can see we have converted the out dot file to png. So now I will open the png file. So this is the uh, tree actually. So you can see how it's splitted here. So the first column which is take is uh, that is petal width. The first attribute is chooses petal width. If that is less than or equal to 0.8 or not. If that is less than, so and then it will separate a category. uh, if it is false, then it will split according to that. So if it's true, you can see less than or equal to 8 petal weights are only be a setosa class. So that's why the value here you can see for setosa we have 37. For other vaginic and vesicular is become 0. So that means it is a pure leaf actually, pure node actually. That's why the Gini index is zero point 0. Okay. So here if that is false, you can see we have values uh, 34 41, 34 vesicular, 41 vaginica. So there is some impurity, right? So you want to split again. So the engineering index is 0.49. So there is some impurity measure. So it is again splitting. The condition is petal length less than or equal to 4.95. Like that it will goes on until you get Gini index as 0. Okay. So all the leaf nodes you can see, all the leaf nodes the Gini index is 0. So it will split until you got a 0 Gini index. Okay. I think it's not colored actually. Wait. Yeah, here filled. So we'll set filled equal to true. Okay, now let's run this. Okay, again we'll choose the file. This one I think. So now you can see it's colored. Okay. Okay, this is how you can visualize the decision tree. Okay, so now we have seen for classifier classification algorithm. Now we'll see for regression algorithms. Okay, so I will just comment this 3 lines and I will load a Boston data from the sklearn load datasets, import Boston. Sorry, that's a function load Boston. Okay, so now it will give you the data. So you want to call the function load Boston and then it will return the data. You want to create a data frame pd dot data frame. So the data is inside the data variable. The key is data here, and then you want to give the column names, columns that are features in the data variable. You want to give the feature names as a key, it will give you the column names. Okay, and then after the target we want to set, the target is inside the data key is target here. Target is the key. Okay, now it will give you the Boston data. Before I will remove all the variables here. Okay, now let's run this. So we got okay, PD is not defined. Yes, we got the data frame. So these are the uh, columns we have. This is a target we are going to predict from CRM CRIM to L state that are independent features. So in that independent features we have seen yesterday, we're not going to use all the features. We're going to select some features from that. So we selected RM and L state and PT ratio also. I think yeah, PT ratio we selected, L state we selected, RM we selected, I think index also. So let's select that columns only. Yeah, actually we are created yesterday the heat map. Yeah, this one I think. So we selected this RM and L state we selected, then PT ratio, and then index also. These four columns we selected. Right. Okay, now for X variable we select the columns data dot, sorry, not data, that is df. No, df dot log. Here all the rows we want, the columns are index, rm, and pt ratio, and L state. Okay, so we want to convert that to numpy arrays, and then y is the target variable, df of target. So this one also we want as a numpy array. Okay, so now we got the x and y variables here. Okay, so the next step will be training and testing. So we splitted the data set, and then what we need to do is, so again we need to fit our decision tree on the data. Unknown label continuous. Okay, wait. Okay, actually this is a classifier, we need to use regressor. Actually that's what the problem is. Regressor, change the name as regressor. Okay, yeah, and now predict the results as is no attribute tree underscore. Sorry, not classifier, regressor. Okay, now we got the predictor results. Now this is a continuous prediction, right? Okay. Okay, you may have a doubt. In classification, we split the data set until the gene index is 0. Okay, so what about the regression type of data? So it will split the data, but the result will be the mean of the results. For example, here uh, we will have only one class, that is setosa or versicolor or virginica, but I will show you. So if you split the regressive type of data based on some conditions like for example index and rm and pt ratio, we have this some types of features. It will split based on some conditions, and then the result will be mean of the uh, if the condition false, then the values will come now. The values we will uh, add the values and subtract it by number of values, that is mean of the values. That will be our result actually. It's not coming here. Yeah. Okay, no problem. Okay, to measure the performance we need to use r square and mean squared error. R2 score, mean squared error. Okay, first we will calculate R2 score, give the test and prediction, and MSC equal to mean squared error. So now the R2 score is 0.63. We can improve that. Let's try to change the test size and random state a little bit. Okay, now that is 0.69. Again we'll try. I think the 10 is best actually. 0.69. set the max depth. Yeah, max depth is 5 set. Then you can see 0.73, it is increased, right? And you can let's try to change the criterion. Now the criterion here is MSC. Also you can use mean absolute error also in the criterion, because it's a regression type of problem. Then we use MSC, that's why it is. Okay, now what other regularization we have? Max features. Okay, I think we'll select only two columns. RM and L state. Now we'll see what happens. 0.62. Okay, I think previous one is best actually. Yeah, 0.73 we get using these four attributes, and the test size is 0.3, random state 10, and then the max depth we are set it to 5. Okay, so this was the decision tree algorithm. You have any doubts, you can ask now. Any doubts? Not tried for regression tree. We'll try for regression trees. I don't think it will come. Let's try. Yeah, it's working. Okay, we'll try to convert. Okay, whoa, it's a very big tree actually. This for regression. Okay, have you any doubts? You have any doubts? I think we can set the maximum leaves. It is a very big tree actually. Okay, the same result using criterion mean absolute error. Okay, so you have any doubts? We'll end up this session now. Okay, I think no doubts. So our website is bigdatahandson.com. You can visit our website. So if you have any doubts, you can message this number 978988844, or you can send email to support@bigdatahandson.com. So the videos will be uploaded in our YouTube channel bigdatahandson.com. If you subscribe to our channel, you will get all the updates. So till part 19 will uploaded. So we'll upload this video as soon as possible. Okay, so we'll see tomorrow. Tomorrow will be random forest algorithm, the same as decision tree, you know that. Okay, so we'll see that tomorrow.
Thank you.